Students, in previous class we have discussed about electricity, just electricity. Electricity can be of two types. One is static electricity, one more is current electricity. Static means charges at rest. Charges at rest. Static. Static means at rest. Electricity. Electricity means flow of charges with respect to time. Suppose you have taken one straw. You have taken one straw and rubbed the straw with any synthetic cloth. Rubbed the straw with any synthetic cloth. This end. Suppose this is one cloth. If you rub the straw with this end, okay, after rubbing, charges will be produced only at this point of the straw, not at here, not at here. Charges will move at this point only. They will not move through the straw. This kind of electricity is called as static electricity. One more example we will take. Take your both hands, rub it. After certain time, charges will produce. Charges will produce due to rubbing. Okay? Because of charges, you feel warmer. Your hands will feel warmer. Means there is some amount of current is produced at that point. Where you have rubbed, there only you will feel current. Not here, not here, not here, not here. Am I right? These charges which are produced after rubbing will not move. They are at rest only. Charges will be produced, but they will not move through the body. This kind of electricity is called static electricity. This is not used in domestic appliances. One example, generally in your home, if there is one 3-pin socket, if you plug in, what will happen? The charges from that point will flow through a wire. If you insert that one, plug in, what will happen? Suppose this is your TV. If you plug in charge, these charges where charges brought by electrical lines, supply lines, starts moving. Yes, charges will start moving to a TV. When these charges flow through a TV, current is produced. Because of current, TV turns on. These charges were not residing permanently here. They will start moving from this point to this point. This kind of electricity is called as current electricity. In domestic uses, we use current electricity, not static electricity. Okay? The charges which moves from one point to another point produces current electricity. Static electricity, I will give one more example. During lightning, rainy season, when there is friction between clouds, what will happen? Charges will produce. Those charges will not move. They will reside at that point too. Yes, during lightning. Okay? And listen here. To move charges from one point to another point, we have to apply some external force. Because of the external forces, the charges starts moving from one point to another point. This external force is called as electric potential. Electric potential. Okay, students, now we will discuss what is electric potential and potential difference. Okay, electric potential in the sense it is work done in moving a unit positive charge from infinity to that point in an electric field. Suppose this is one electric field. Okay, to move this charge, to move discharge from one point to another point, we have to apply some force. We have to apply some energy against the repulsion force. Against repulsion force. Suppose this is one positive charge. This is one more positive charge. Okay? Yes. To generally, these two will repel each other. These two will repel each other. But you have to move this charge towards this. You have to move this charge towards this direction. Then you have to apply force against the repulsive force. Because of this force, this unit positive charge will move from one point to another point. That force is called as electric potential. Once again I will define. Suppose this is one electric field. Inside the electric field there are charges. Inside the electric field there are charges like this. Okay. What you are doing, between these two positive charges there is a repulsive force. These two will repel each other, means move away because they have same kind of charge. But to make this charge move towards this charge, we have to apply some force. That force itself called as electric potential. Okay? Let's see it. Work done in moving a unit positive charge from one point to another point in an electric field is called as electric potential. Okay? Next, we have potential difference. According to this, the amount of work done in moving unit charge from one point to another point is called as potential difference. Electric potential turns into potential difference. Potential difference is potential difference. Potential difference, which is denoted by V equals to work done by charge. Students, this is a conductor material before giving potential difference, before connecting cell or battery. See, the cell or battery is not connected. See, they are not connected. By this time, the electrons are moving randomly in different directions. The electrons are not moving in a particular direction. They are moving randomly. This electron is moving in this direction. This electron is moving in this direction. This electron is moving in this direction. Okay? If I connected this cell or battery properly, see. If I connected this cell, this is higher potential and lower potential end. Okay? Yes. These electrons now starts moving in a particular direction. And these electrons now produces current inside this conductor material. Current is produced inside this conductor material by connecting cell or battery. What happens after connecting cell or battery? Before connecting cell or battery, the potential at both the ends is zero. Potential at both the ends is zero. Okay? After connecting cell or battery, there is a difference in potential. One is at higher potential, another one is at lower potential. See, if you connect a 3 volt cell, what will happen? One terminal will have 3 volt, another terminal will have 0. Still getting confusion in a sense, I will show one very best example. Water also has charge. Moving water produces current. You may be familiar. Just beside your TB dam, Tungabhadra dam, there is one powerhouse. Okay, when water flows from dam's crest gate, higher potential to lower potential. Water moves fastly, higher to lower potential. This moving water as charge, that is produced what? That is produced into current. Okay. Suppose if you take a plate, your lunch plate, pour some water, hold it perfectly horizontal. Hold it perfectly horizontal. Does water move? No. Just tilt your plate. What will happen? Water moves from higher potential to lower potential. When water moves, the charges also moves. Okay. Same case. When potential is same, like your plate, when both the ends have same potential, charges will not move. So there is no flow of current. When you tilt your lunch plate, what will happen? One terminal will be at higher potential, another one will be at lower potential. Now charges move. When you connect cell or battery, what will happen? There is difference in potential. One will have 3 volt, another one will have 0 volts. Now charges moves from higher potential to lower. Okay, so now we will learn SI unit of potential difference. As you know, potential difference makes charges to move from one point of the conductor to another point of the conductor. Once charges move, they produce electric current. To produce current, we must develop potential difference. This potential difference is measured using a unit called volt. It is also the name of the scientist. Okay, we can define 1 volt or potential difference between two ends of the conductor. Suppose this is conductor terminal 1, conductor terminal 2. Okay, the difference between these two conductors, potential difference, is said to be how much? 1 volt when 1 joule of work is done in bringing 1 coulomb of charge. Suppose this is a charged particle. These two are charged particles. Okay. If these two charged particles brings a charge of how much? 1 coulomb. From where? One point to another point. Work done in bringing a charge of 1 coulomb from one point to another point is termed as 1 volt potential. Okay, students, we will solve one numerical based on potential difference. Okay, what has been asked in this problem? Listen, how much energy is given to each coulomb of charge? Imagine there is one conductor. It has some charges. Yes. Let this be one charged particle. Each charge, how much energy is given to each coulomb of charge passing through a 6 volt battery? This is 6 volt battery. Okay. Suppose each coulomb of charge. Each coulomb means, what is charge here? Charge Q equals to 1 coulomb. What is potential difference here? 6 volt. What we have to calculate here? We have to calculate the energy. Means each charged particle has been producing how much energy, that we have to calculate in this problem. Okay. We'll go through given data, given charge. What is the charge on each charged particle? 1 coulomb. What is the potential difference here? That is V equals to 6 volt. What we have to calculate? We have to calculate work done. According to the formula of potential difference, we know that potential difference V equals to work done by charge. What we have to calculate here? W. Just rearrange this equation. W equals to V into Q. V is how much here? 6. Q is how much? 1. So 6 into 1, 6 joules. Okay. Is the energy carried by each charged particle Okay students, this is our second numerical. Here we need to calculate work done on a charged particle of 2 coulomb when it moves from a point at 118 volts to 128 volts. Means this is one conductor. Okay, suppose a charged particle, this is point of 118 volts. This is point at 120 volts. Okay now? Yes. Where we have charged particle, the charged particle is here. What is its charge? It is having a charge of 2 coulomb. Okay? To move this charged particle of 2 coulomb from a point at 118 volts into point at 120 volts, how much work has to be done on this charged particle? That we have to calculate now. Okay? Yes. Solution. Q is how much? Q is given 2 coulomb. Q is given as 2 coulomb. What is V here? There are two values of V. So we have to take this as V2, this as V1. Higher potential minus lower potential. 128 minus 180. So V equals to 10 volts. V equals to 10 volts. What we have to calculate here? Work done on this charged particle. That is given by W equals to V into Q. Or we can write basic formula only. We know that V equals to W by Q, or W equals to V into Q. V is how much? 10. Q is how much? 2 coulomb. So 10 into 2, 20 joules. W equals to 20 joules. 20 joules of work has been done, or the energy transferred to this charged particles is 20 joules when it moves from a point at 118 volts into point 8